Have you ever wondered what lurks in the depth of a shadow? What if shadows could hold more than just darkness? Welcome to the intriguing world of shadows. These seemingly mundane patches of darkness that we encounter every day are, in fact, a fascinating spectacle of nature. They are formed when an object blocks light, casting a silhouette that mirrors its form. However, the shadow's shape, size, and intensity can vary based on the light source's distance and size, making shadows dynamic and ever-changing. But let's take a step back and think about what a shadow really is. It's not merely an absence of light. In fact, it's the interaction of light with the physical world. It's a natural phenomenon that is as much a part of our reality as the objects that cast them. And this understanding leads us to a thought-provoking question. Could shadows potentially hide entire worlds? Now, this might sound like a concept straight out of a science fiction novel, but it's a question that has intrigued physicists and philosophers alike. The idea that a shadow could be more than just an area of darkness, that it could be a gateway to another reality, is not as far-fetched as it may seem. Consider for a moment the intricate patterns of a shadow cast by a leafy tree. There's a complexity there, a certain depth that seems to hint at something more. Could these patterns be a kind of coded message, a hidden language of the universe waiting to be deciphered? Shadows in their elusive nature challenge our understanding of reality. They are entities that exist in our world, yet they lack substance. They can alter their form and size, yet they are not tangible. They can hide things from our view, yet they can reveal details about the objects that cast them. If we start to view shadows not just as absence of light, but as entities with depth and mysteries, we open doors to fascinating possibilities. So, next time you see a shadow, take a moment to ponder. What if, within its dark expanse, lies the answer to mysteries that stretch beyond our current understanding of the universe? It's a tantalizing thought, isn't it? In the realm of quantum physics, nothing is as it seems, not even shadows. In the quantum world, shadows are more than just the absence of light. They become a metaphor for the uncharted territories of our understanding. One such unexplored area is the concept of dark matter. Dark matter doesn't absorb, reflect, or emit light, making it invisible. Yet it's believed to make up about 25% of the universe. If we think of our knowledge of the universe as a lit room, dark matter is the shadowy corners where light hasn't reached yet. Now let's delve deeper into the quantum shadows with the theory of shadow particles. These particles, also known as shadow matter, are a hypothetical form of matter that interact only weakly with the ordinary matter we're familiar with. It's like having an invisible twin that lives and moves alongside us, creating a shadowy parallel reality that we can't see or touch. But wait, it gets even more mind-boggling. Some physicists propose that our universe may be just one of many, existing in parallel to each other. These parallel universes might be right here, overlapping with ours, only hidden in the shadows of our perception. Each shadow could be a window, a glimpse into these parallel realities. Quite interesting, isn't it? That the simple shadow cast by an object in the light could be so much more than it appears. But this is the beauty of quantum physics. It challenges our understanding, pushes the boundaries of our imagination, and forces us to question the very nature of reality. In this light, or should we say, in this shadow, the darkness becomes a symbol of the unknown, the unexplored, the unexplained. It becomes a reminder of how much there is still to discover, to learn, to understand. Quantum physics thus suggests that shadows might be more than just a play of light and darkness. They could be gateways to other dimensions. So the next time you see a shadow, remember, it might be hiding a whole other world. Time, the ever-flowing river that carries us forward, but could shadows have a different relationship with time? In the realm of physics, time is not as straightforward as it appears. It bends, stretches, and even slows down under certain conditions. This is the concept of time dilation, a key element of Einstein's theory of relativity. Now imagine if this same principle could be applied to shadows. In the quantum world, shadows aren't simply areas where light is absent. They are complex entities with their own unique properties. Some physicists have suggested that within these shadowy realms, time could behave in ways that are truly astonishing. Picture a shadow as a parallel universe, where time is not a one-way street but a winding path that can loop back on itself. In these shadow worlds, the future could influence the past, and cause and effect might be interchangeable. This is a concept known as retrocausality, and it's as mind-boggling as it sounds. But how could this be possible? The key lies in the nature of shadows themselves. They are not just lack of light, but a result of the interaction between light and matter. Quantum physics tells us that particles can exist in multiple states at once until observed. This is the concept of superposition. Could it be that shadows too exist in a state of superposition, with multiple versions of time occurring simultaneously? This idea might seem outlandish, but in the quantum world, the impossible often becomes possible. Imagine then, stepping into a shadow and being able to travel to the past or the future. Or experiencing time at a different pace, slower or faster than the world outside the shadow. These are just theories, of course, but they open up exciting possibilities for understanding the universe. If shadows can interact with time in such unusual ways, our understanding of the universe could be fundamentally altered. What if within every shadow, there lies a hidden world, unseen and unexplored? Now let's delve deeper into this captivating realm of thought. Theoretical physicists have proposed theories that suggest the existence of parallel universes within shadows. Yes, you heard it right. Entire universes might be hiding in plain sight, within the very shadows we see every day. Imagine a shadow cast by an object. Now, instead of perceiving it as merely an absence of light, consider it as a window, a gateway to another universe. A universe with its own laws of physics, its own stars, planets, and perhaps, its own life forms. It's a mind-bending idea, isn't it? But what could be the characteristics of these shadow worlds? Well, as they are theorized to exist within the quantum realm, they might not adhere to the rules of time and space as we know them. Time might flow backwards, or not at all. Space might be infinitely curved or flat. The possibilities are as boundless as our imagination. And what about the implications? If these shadow worlds do exist, they could potentially revolutionize our understanding of the universe. They could provide us with entirely new perspectives on the nature of reality and challenge our most fundamental beliefs. Imagine for a moment that we could somehow access these shadow worlds. What kind of technology would that require? What kind of knowledge might we gain and at what cost? These are the questions that keep physicists awake at night as they ponder the mysteries of our existence, but let's not get too ahead of ourselves. These theories, as fascinating as they are, remain largely unproven. They are the product of our relentless quest for knowledge, our insatiable curiosity about the cosmos. However, the fact that we're even considering such extraordinary possibilities is a testament to the power of human imagination and the unyielding spirit of scientific inquiry. After all, as we've learned from history, today's science fiction often becomes tomorrow's science fact. These hidden worlds, tucked away in the folds of our shadows, could hold answers to some of our greatest questions. So, why do physicists believe that shadows hide entire worlds and collapse our notions of time? This question has led us on a fascinating journey today, one that has taken us through the intriguing realm of quantum physics and into the heart of the shadow world. We began by unveiling the mysteries of shadows, exploring the idea that these seemingly simple, darkened areas are more than they appear. They are not merely the absence of light, but rather complex phenomena shaped by the interplay of light and matter. Then we dove into the quantum world of shadows, where things are not as they seem. We discovered that shadows are not just the result of light being blocked, but they're also influenced by the strange and surreal rules of quantum physics. Here, particles can be in two places at once, and their behavior can be altered merely by observing them. We then journeyed into the relationship between shadows and the illusion of time. We discussed how shadows, in their constant dance with light, can distort our perception of time. We explored theories suggesting that the shadow world could exist in a timeless state, where the past, present, and future coexist. And finally, we delved into the concept of hidden worlds within shadows. Theories suggest that these shadows could be windows or portals into other realities or dimensions, ones that exist beyond our normal perception. These hidden worlds could have different laws of physics, different forms of life, or even different concepts of time and space. So why do physicists believe that shadows hide entire worlds and collapse our notions of time? Because the world of shadows is a world of infinite possibilities. They challenge our understanding of reality, question our perception of time, and open the possibility of unknown worlds lying just beneath our feet. As we continue to explore these theories, we may find that our shadows are not just silent companions, but doorways to the unknown.